Today we begin the study of trig, trigonometry, which all it is a fancy way of saying is it's the study of triangles, and it's a tool that's going to allow us to answer some questions about triangles. So first, again, like it says, just some background at the top. So it gives me triangle ABC. I went ahead and labeled my triangle also sort of like ABC, like I could do Pythagorean theorem, a squared plus b squared. So I just relabeled it with little letters also. So it says, name the hypotenuse of triangle ABC. Again, the hypotenuse is always the side opposite from the right angle, and it's always the longest side of the triangle. So I can call it side AB if I'm going to use the two vertices, or I can just use the C, because if I'm using Pythagorean theorem, that would be the C. That is the hypotenuse. Name the side that is opposite from angle A. Okay, so here is angle A. The side opposite from it is right here, is side BC. Side BC, or of course I can call it little a. Name the side that is adjacent to angle A. Okay, we're not looking at the hypotenuse. Do not look at the hypotenuse when I'm talking about the adjacent or opposite sides. So I'm looking at, name the side that is adjacent to angle A. There's angle A, not looking at the hypotenuse. We're talking about this side right here. So that is side AC, or of course I could also call it little b. And then name the side that is opposite from angle B. Here is angle B. The side opposite from that is side AC. Of course I could also call it little b. And then I've got one more. Name the side that is adjacent to angle B. Again, here is angle B. We don't want to count the hypotenuse. So we're talking about side BC, which again I could also call little a. So that's just talking about familiarizing yourself with what it means to be an opposite side and an adjacent side. So that'll help you if you're comfortable with this. I think what we're doing today, I think you'll find is not too bad. There's an acronym that we often use to talk about trig. It's called SOHCAHTOA. SOHCAHTOA. Again, you don't have to memorize this. You'll have this on a formula sheet on any test I give you and on STAR. But of course, the more familiar you are with it, the easier it's going to be. All the SOH means is the S stands for sine, the O stands for opposite, and the H stands for hypotenuse. So the SO means that the sine of angle X equals the opposite side over the hypotenuse. Again, I'll explain more in a little bit, but that's what SO means. The CAH, C-A-H, the cosine of X equals the adjacent side over the hypotenuse. And the TOA just means that the tangent of X equals the opposite side over the adjacent side. Okay, little picture. Just talking about the sine right here in my little picture. So I've got a little triangle drawn in there, and I've got it labeled. So the sine, I've got triangle ABC, and I'm talking about the sine of angle A. So if this is angle A, then this is the hypotenuse. That makes this the opposite side, because it's the opposite side from angle A, which of course makes this the adjacent side. It's the side touching angle A. So if I'm talking about what is the sine of angle A, it is this opposite side, whatever that length is, over the hypotenuse, whatever that length is. It's just the ratio. That's all sine, cosine, and tan are. It's a ratio of the side lengths. The sine is just asking you to take whatever the opposite side of that angle is and put it over the hypotenuse. Okay, so the cosine, again, very similar. Another triangle I've got drawn in there. Same triangle, triangle A, B, C. Still talking about angle A. The cosine of angle A equals, again, it's the CAH, C-A-H. The cosine of A equals the adjacent side over the hypotenuse. And the tangent is just the opposite side over the adjacent side. So if you're asked to find the tangent of angle A, you would put the length of the opposite side over the length of the adjacent side. It's just a ratio. Okay, so if I did that specifically on these, again, going back to my problems, if you're asked to find the sine of angle A, it's equal to the length of the side opposites from angle A. If I look at that in my picture, it is side length BC over the length of the hypotenuse. And the hypotenuse is just the length of AB. So if I knew how long those side lengths were, I would divide the side length of BC divided by the length of AB, and that would be equal to the sine of angle A. Same thing with cosine of A. Very similar. Cosine of A, I find the length of the side adjacent to angle A, which in my pictures is side AC. And I just have to divide that by the length of the hypotenuse, which is still AB. So I would just divide out these two numbers, and that would be equal to the cosine of A. And the tangent of A is just the length of side opposite angle A divided by the length of side adjacent angle A. So in my picture, side length BC divided by side length AC. On the back, it gives us some problems. Again, I just wrote it at the top. Just sort of get in the habit of writing that down. SOHCAHTOA. So that's what I'm going to reference. So first thing, notice it does not give me the three sides of my triangle. It tells me that that is 20, gives me that is 12. But all I have to do is the Pythagorean theorem, and I can figure out that this length is 16. So now I have the three side lengths. This first part just asks me for the sine of angle A. Well, the sine of angle A, again, is the opposite side over the hypotenuse. So here is angle A. The opposite side is 16. That goes on top. Over the hypotenuse, which is 20. Of course, 16 over 20 I can reduce to 4 over 5. That's it. It's that simple. It's just a ratio. The sine of angle C, here's angle C. I take the opposite side, put it over the hypotenuse, and I get 12 over 20. Reduces it to 3 over 5. The cosine of A, here is A. The cosine says you take the adjacent side and you put it over the hypotenuse. 12 over 20, which is 3 over 5. Notice the similarity here. Then I go cosine C, here's C. Take the adjacent side, which is 16, put it over the hypotenuse, which is 20, reduces to 4 over 5. Notice the similarity between these two. Tangent. Tangent of A says to put the opposite side over the adjacent side, which is 16 over 12, which is 4 over 3. And the tangent of C says to put the 12 over the 16, which is 3 over 4. This is important. When we are doing trig, be sure your calculator is in degrees. I don't know how well this is going to show up. But on my calculator, see where it says mode? You have to make sure, let's get out of here, you have to press the mode button. Notice at the top where it says radians and it says degrees, you have to make sure that it is the degrees that is highlighted, or else you're going to get the wrong answer every time you do this. It's in the mode. I wrote it right here. Be sure you know to go into mode. So all I'm going to do is I'm going to figure out, okay, what is the cosine of 68? All we have to do is hit the cosine, hit 68. There it is. It is 0.3746. That's what I have. If you're asked to find the tan of 12, you hit the tan button, you hit 12, and it's that decimal number right there. If you're asked to find the sine of 53, we hit the sine button, we hit 53 on our calculator, and we get that number right there. It's that simple. Okay, now when we have to work backwards, notice we're not given the sine. But actually we are, yeah, we're given the sine now, and we're asked to figure out what the angle is. So if we know this is the sine, what must the angle have been to give us this sine? When we work backwards, you just hit the second button first. The second, we're trying to find sine, so I got to do second sine. See if I can get that to show second sine. It'll look like that, and then I type in what I have. 0.6428 parentheses, and it gives me the angle. Roughly 40 degrees. Not exactly 40, but pretty close. So again, now I'm told that the cosine of B is 0.26. So I'm trying to figure out what angle, when I took the cosine of it, gave me 0.26. So I hit the second button, I hit the cosine. Notice it gives me the little inverse operation. I do 0.26, enter, 74.9. So the angle must have been 74.9. And then the last one, I'm told that the tangent of C is 5.6. So what the angle is, I hit second, I hit 10, I hit 5.6, I hit enter, and there's my angle. Again, lots more examples in class. Don't worry if it's not getting to you right away. This one tells me, again, a little bit of algebra to do here first. I have the sine 65 equals x divided by 10. I cross multiply and I get that x is equal to 10 times the sine of 65. I can type all that into my calculator and I'll get roughly 9.1. This second one tells me that the tan of 86 equals 12 divided by y. Cross multiply and I get that 12 equals y times the tan of 86. Divide both sides by the tan of 86 and you'll get that y equals 12 divided by the tan of 86. And if I put all that into my calculator, I'll get y is equal to 0.8. Try this last one. Think about, this one's not going to work. If you don't have a, this one will not work. Think about why this is undefined and will not give me an answer.